Alright, hello, I'm Zing, and today we're going to be using the Ursina engine in Python. It's a game engine, and it's pretty cool. It makes things really simple, especially when you build a 3D game. I'd say it's pretty cool. So we just have a simple Python file and a folder. Maybe later on in this tutorial if we continue it. My chosen editor is Sublime Text, and I actually have no idea where I'm going with this, so I do not have any code to read off of, and I don't have anything to see. So we'll make sure we can see this here. We're going to be trying to build a racing game. That is the goal. Maybe simple. We're going to start simple, but in the end, we're going to go for a simple game with maybe like a racing theme kind of goal. I don't really know what defines a racing game as a racing game. So simply, we import Ursina, then we create an app of Ursina where we can define our settings, but we're not going to define any for now. And at the end of it, we're going to run the app, which is, this is a Panda 3D module or whatever. It just makes everything really simple, and I'm too lazy for that. So, easy window with vsync on, because it's automatically on. If we create an entity here, we can see we can call it a player entity. We give it a model of quad, so a 2D model here. It's a cool little model. For things, we're actually going to be making this in a class, so I hope you understand classes, because I sure know I don't. Just kidding. So we need to reference the entity. I think that's what it's called. Make it like a child, or it's an entity, I guess. I don't really know how to explain it. I just know it works. But yeah, we want it to make it a entity, and then we can super that entity, or make it the entity, I guess you would say, and we can give it a model. Oh, self.model, because that's what the class is, to instantiate. Like when we get a variable, self is going to be pretty much that variable. So self.model quad, and no. Then we can make a player, or we'll make it a car, and actually, yeah, we'll make it car. We'll make this car, and then we can make our car and in a instance of car. And on app.run, we have a quad. We can give it an update. Give it self, so it can instance the class, and then because it's gonna give us an error if we don't. And then we'll just, for now, we'll just say self dot x plus equals 1, and we'll see it just goes very, very fast, and I didn't include that. Some of this might be edited out, some of it might stay in. Who knows? We can give it a self dot speed, and I'm separating that from the quad because you could instance the quad in here, but sometimes I might need to use it, and I don't exactly know everything about a super in it. Whatever you might call it. So we can give it a speed, we'll give it around 2. So then we can, if we multiply this by time dt, so frame references, I would say, then we can multiply it by our self.speed, and you'll see it goes a little bit slower, which is cool. Alright, we're also going to give it a velocity. And velocity is going to be a vector 2 of not plus vector 2. It's going to be a vector 2, which is going to be 0, 0 for now. Vector 2 is just a Panda 3D. We can check the documents real quick if we go here. We can go to vector 2. We can see it is a Panda vector 2, and it just takes 2 arguments, an x and a y. So we're going to be using the Panda. Not Panda. We're going to be using a vector 2 for velocity. So we can say velocity. So we can say self.velocity plus equals 1, and then we can say, velocity.x, and velocity.x, self.x is plus our velocity.x. And again, it just moves way too fast. So there's held keys, which is a form of getting input, and it's one we're going to be using because it's smoother, I assume, I don't know. And we can give it a list, we can give it a, I don't know what to call it, well, you can, we can see if A is in the list. It's really simple, and it'll if it's not there, it's going to return 0, and if it is there, it's 1. So we'll actually say, we can do plus equal for now. Multiply by time dot dt multiply self dot speed. All right, and then when we hit A, it's actually going to go right, but that's not important. So then we want to remove our x, because now it's just going to infinitely go. So self.velocity.x minus equals self.velocity.x divided by, let's go for 3 for now. Alright. And we have a stopping cube. Pretty cool. We can actually put this within this and also add our other key, which is going to be held keys. And we want to do, we want to have D here. So D moves us, that's backwards. So then we want to have A and D. And I'm hitting D and I'm hitting A. And you can kind of see it's a little bit of a smooth stop. So we can actually divide it by a higher number to have a smoother stop. But we also have that little speed problem where we don't actually have a speed cap. So I'm pretty sure we're going to try this here, because again, I have no code to go off here, but we're going to try to see. So self.velocity of x is less than self.speed, then we'll allow it to be added to, and I forgot to give this a number again. And no, that didn't work. Of course it didn't work. Why would it work? We'll just get a quick see here on what's going on in velocity. We want it to be less. Yeah, we want it to be less than. Because velocity x. What we can do here, I believe, instead of all this. Nope, we're having a problem here. Is not added to its full potential either. Oh, that needs to be that. And, well, we have a slow movement, so we won't divide it by as much. So we'll divide it about 10 before we add to the x. And we kind of have acceleration going on here, which is pretty cool. I think that's the goal. Have acceleration going on. Let me hit 0 again. We can change the scale, so self.scale is going to be equal to scale equal to a vector 2. So we're going to set the this quad is going to have the scale we give it. So if we give it 0.5.5, it's going to be half the size it was earlier. You can see we can still move it down. And when we hit D, we're actually not instantly going the other way, which a car would kind of do, but that's not exactly what we want to do. So we're actually going to do another statement. If we're going to say if held keys, which is going to be keys that are held down, W. So now we're going to know if W is held down, then we're going to say self.position plus equals self.up. So this is going to say what is its up. Like if it's looking, the top of the square is going to be what we're going to. So we're going to get self.up multiplied by time.dt multiplied by self.speed. And that lets us go up, which we actually want to. This is actually this is useless now, but it was a concept kind of thing that kind of saw how we could move with that. So we're gonna use that. Now we're gonna have if held keys. Actually, we could do self.rotation plus equals a vector 3. 0 because the spinning on the x and the y will do nothing for this 2D. So we want to spin it on the z-axis of held keys A minus held keys D. And that rotates us backwards. Of course it does. It's the same thing as last time. So we want to say held keys D and A. And now we're going in the direction we turn, which is what a car does. Crazy. Crazy. We can spin, and that's cool. So speed is really low now, so we want to increase our speed here. You can see that we go with our car. Well, we need that velocity variable again, so we'll create self.velocity plus equals this, and then self.position plus equals self.velocity. And oh, that's plus, no, plus equals. And we get a little error here, and it says index out of range. Self.velocity. Oh, because this is a vector 2, so give it a vector 3, give it an extra 0 here. Oh, and it goes insanely fast. No problem though. Again, we need to reduce the velocity, so self.velocity equals self.velocity. I think this is an error because we're trying to divide a list. No, it's not. Alright, well that's cool. right now while it's off screen. That'll be a problem we'll fix later by moving the camera on with it, because this has a camera. Yeah. Actually, I think we want to do this. Nope, that was a problem. We want to subtract it by something like this. And we see we still get that problem earlier. And I think, again, our solution is just as simple as this. And you can see we have some slower movement. And for now, I think that's going to do. We can actually do this too. So we can gain speed. We see we actually are gaining speed at this point. So the longer you're holding W, the more you gain speed. You can't edit that around. We'll go with around the variable of subtracting velocity by velocity divided by 15, which gives us a little bit of a slowdown, so you don't slow down too fast. Alright, so now we have a car that we can move with W and turn with A and D, which is pretty important. We also want to be able to brake with S, so let's add that. If we want to add an if statement, and if held keys, we want to check for S, is self.velocity, velocity plus equals self.down, which is going to be the exact opposite of up, multiplied by time.dt, the offset I believe, and speed. And that's an S. So S kind of shoots us backwards here, but not too much. I think that's fair. If we go here, for now we have a car that goes forward and a car that goes backwards. We can even give it a color here. Vector scale self.color equals new color.rgb. We can give it 0, 0, 0, which is going to be black. And we can make it we'll go for blue car now, and we'll make it slightly lighter by increasing the other variables. Maybe slightly up. No, that's a purple car. Well, kind of hard right now to currently tell which way it's looking, but for now, that's going to work. What next we need in the car is, of course, collision. We don't want it to just go through anything, so we're going to give it a raycast here. It's going to be equal to a raycast. I know, crazy. And it needs a direction, I believe, so we'll give it our self.up, and we'll make sure debug is true, and it also requires a distance. So for now, we're going to give it a distance of infinity. That's infinity. I don't know what that means. Infinity, what's our problem? Origin. Direction is actually what it needs to be. Our direction needs to be origin. That's not, what is that? Origin. Got unexpected origin. Oh, we need to run it again. Unexpected origin. Distance, what is it gonna say? Missing argument, repeated distance. Oh. We're just going to give it D. Let's see what it says. Well, because what you're supposed to do, go over here and actually look at it like you're supposed to. So, raycast and a raycaster. And we can see it needs an origin, a direction. Origin. Alright. So, direction is what that is. So, it needs a direction, distance, and debug. Right. So, what we want is to give this the direction, but our self.world position is going to be this. And there we go. We have a raycast that is coming out the front with the same side that we are trying to move. So we will require the distance to be a little bit smaller. Wee bit smaller. That's good enough. So now we have a raycast that is going in the direction we're trying to go. We can also make one that comes from the back, so we'll give this self.forward R, that's what we'll call it. Forward R, see, raycast, and then we can copy this raycast, do the exact thing. We can only have one that debugs, so we're actually gonna make this one true still, and that one won't show up. I don't exactly know what that's about, but it does what it does, so we don't complain. Self down, we'll call it forward reverse raycast. And, well, yeah, we're going in the exact opposite direction of this raycast now. So we're going to go ahead and get ourselves a square. So, square, square is going to be equal to an entity with a model equal to quad. and a collider equal to a box collider, which is a 3D collider, but does not matter since in this context it's not moving within the 3D plane. So it's still just a quadrilateral or square collider. So that's all that matters to us, and we'll give it a position that's not where we spawn, so we don't have any glitches or something. So a position of around, we'll give it a vector 2, because I just typed that, because it's going to be converted to a vector 2 eventually anyway. So we'll give it like 3 and 3. It's going to be up here, and well, there's one thing. We don't actually need to test it yet. And self.forward rc.hit. And we want to say not, so it's not true. And we're actually going to do one last thing before we set this to false. So oops, set this to false. And you'll see we miss it. That's what happened. I'm just going to reset because I'm going actually pretty fast. And you see it doesn't actually work, and that's a small problem here. We got to figure out why it doesn't work. And that's the beauty. So we're saying and not self.forward rc hit. Let's print self.forward rc.hit, which is going to say if it's hitting a object. It's all false, 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 it's false. So it's still, oh no, it's true now. What is going on? Oh wait, was it working this time? What is going on? Alright, we're going to come up on it, we're going to come up on it. We're having things happen here. So it has a collider model, and we have a forward RC. We're printing if it's hit. We could. Okay, so we're adding I might skip. If I can, I'll figure this out. So just don't expect too much talking here. If it's not, we actually do accelerate really fast. we're gonna remove some of that speed so we don't accelerate so fast. We actually don't. So we're still. I understand. If self forward RC, we want to set it before the S so we can still reverse away from it or turn. Because so self.forward RC dot hit then velocity z equal to 0, and we should have still not working collision, because why not? Well, is that it? Is that the, did that work? Turn around. There we go. Working collisions. We're actually going to give ourselves a turn speed here. So self.turn speed. I've typed a lot of other projects, so it's going to auto-complete. Sublime is pretty cool. So is VS. I just don't use it. We'll give it a turn speed of around 2. And we're going to multiply the output of this by self.turn speed. And now we can turn a wee bit faster. I'm pretty sure I should multiply this by time.dt first. No, we shouldn't. It's a rotation. I mean, we'll figure that out later if it becomes a problem. But now we can turn it a little bit faster. We can't run through walls that have box gliders. We can give ourselves a box cast so that we can't have that going on. Oh, and that's a wee bit of a glitch there. And we can rotate through this, which is not so good. Or rotate into it, but I think we're going to end up swapping to box casts, which we can just make it a whole box in case when later we have a car or something. So now we're going to check the same thing here. We're going to say and not self.reverse rc.hit, and if self.reverse rc.hit self.velocity equals. Now this might cause a problem for the fact that this is before we add the rotation, but let's figure it out. No moving forward, no moving backwards, and no moving. Oh, what was going on there? Actually, I think the only reason it worked, like, if we do this and we hit W, it does not work. So if self.rc.hit, we also want to make sure and self.velocity is equal to self.velocity negative version. Almost we need two equals. That may work. So no collision here. We can reverse actually. Alright, we don't. Alright, we're checking now to make sure that W is not being hit. Now this might be a problem for, like, if you can hold down both keys, but this is not something we ran into before. I am turning the wrong direction, I forgot. Ooh, we have a problem here. Car object has no attribute. Held keys, it's held keys, and this is held keys. What is our problem here? I am trying to figure it out. And not so what we're gonna. Oh, I typed self. We do not have that attribute, and Python was right and I was wrong. Just simple logic. It happens all the time. And we see we can actually back up now. So boom, can't run into a wall. I can back up. We're gonna try one more time. We're gonna back up here. We cannot back up anymore. We can't go sideways and into it like that, but that just happens, and we can reverse right out of it, holding W and hitting S, and I'm just not moving at all now. So yeah, that is our solution to that. So now we can run into walls. I believe there is actually something already for smooth follow, but we're gonna start really simple and just have a entity. I believe I can say camera.position. Let's just check. But if I cannot, then we'll just do a simple workaround. That doesn't seem to work. We're going to try a bigger number to make sure. It does work. Alright, it does work. It does work. It does work. So we're going to just say define update here. No self because it's not within the class. We're going to pass for now. And then we're going to take this camera position, copy it, put it in update, not pass. So camera.position is actually going to equal to our car.position. And for now, that doesn't work. Alright, little small break there. That did not seem to work. I can only wonder why. We do not have a working camera here. So we're trying to set the camera position to the car position, but that's not working. What if we set the camera's X, which you can try to set the camera's X to the car's X. And we can see that if it moves to the left and right, we can still see it. And if we say camera.y equal to car.y, it still works. Alright, so we're just gonna pause for a second and be right back. Alright, last little skip. Sorry. So we should be able to set the camera's X and the camera's Y right here to the car's X and the car's Y. And now we have a car that collides with the box like that, and it reverses. It gradually gains speed. We can turn these colliders off in a second. We can reduce their speed. We can also add more, like a left and right one to stop the car from turning left and right. But that will be in the next one, since this is getting a little bit long. Let's go over what we did. We made a class, an entity class that's called our car. We set a super in it so we could define its things. We gave it a model of a quad. We gave it a scale so it's smaller. We gave it a color so we can see it like that. We have a speed variable, a turn speed, and a velocity that is being used, yes. We have a forward raycast, a reverse raycast, so we can determine if they can go forward or not. We're determining if held keys is 1 and not self-forward or RC hit. So if we're not hitting something and we're hitting W, then we'll add the velocity. If it's hit, then we're gonna set it to 0. If it's if held keys S and it's not reverse C, so if we're holding S and the reverse raycast is not being hit, then we're gonna subtract from the velocity. We add to the velocity by down, but that's just subtracting better. I guess. And then if self-diversity are hit and we're not holding W, so if the left back one is hit but we're holding W, well, we're not holding W, then we'll still sub-0, so that you can't go backwards. In the end, we add our position by our velocity divided by 10. Our rotation is a vector 3, so 0, 0, because that does not matter in terms of 2D space. And then we're taking held keys D, so if D, the D key, and the A key, so D minus A, if it's being held, multiplied by our turn speed, so we add to that. If it's A, then it's going to be going left, it's going to be -1. If it's D, then it's going to be +1, then we multiply by our turn speed. And then in velocity, we subtract it by velocity divided by 15 to give it a nice little smooth slowing down effect. Letting go of W and holding W. The next one, we might be adding a actual car, so we can have like a car image. And, well, because I don't have anything to go off of here besides, no, I don't really think I have anything for this one. So I think we're really going in the blue here, and if you have an idea, please comment it, or just say if you like this. Thank you for watching, and bye-bye.